Hi everybody, so we're back, and I wanted to wrap up linear equations by doing two examples. One, the method we talked about first, so analyzing a graph by looking at it and finding the equation of the line, and then the other way, given two coordinates and finding the slope between them, and then finding the rest of the equation. So before we get into it, let's just review, right, that equation that we're referring to, which is one you should definitely remember. y equals mx plus b. So, right, super important and basic equation that we talked about that I will ingrain into your mind, I hope. And I hope that you remember what the m and what the b represent. We said the m was the slope, and the b, I hope you just said y-intercept, was the y-intercept, right? So we have these two things, and now we're going to practice again how to find that slope and that y-intercept. So let's start with method number one. I'm going to zoom in a little bit so we can see it better. Let's start by finding the rise over run, right? Remember we said slope is the same thing as rise, or how many we went up or down, divided by the run, how many points we went to the left or to the right. So in this situation, let's start. Doesn't matter if we start down here or at the top, and you'll see why in a second. So let's start. I'm going to start down here. Let's say we went to the left in the negative direction by 2, and we went up 1, 2, 3, 4, 5, 6. So our rise, we went up by 6, positive 6. We went up, so positive. And then our run, we went to the left in the negative direction by 2. So negative 2 is our rise over run. So if we simplify this fraction, we know our slope is negative 3. So in general, when we have a linear equation or a linear function graphed and we see it going up and to the left, that means our slope is negative. If we have a graph going up and to the right, like this, that would be a positive slope. So that's just a note for any linear equation. Okay, great. So we found our slope, and now let's see. How do we find b, right? So now we have y equals negative 3x plus b, and we need b. So usually on a graph, the nice thing is that we usually don't have to solve for b because we can usually see where do we cross the axis. And it looks like it's here, although it's pretty hard for us to tell, but we can assume 1, 2, 3, 4, 5, b is going to be 5. If we want to check that, if we're not 100% sure, remember we can always plug in a point for x and y and solve for b. So let's just plug in the point that we started with here. That's 1, 2, 3 in the x, and 1, 2, 3, 4, negative 4 in the y. So negative 4 equals negative 3. Ooh, these 3's are a little close. 3 times 3 plus b. Okay, negative 3 times 3 is negative 9. And if I add that 9 over here, I'm going to get a 5 equals b. So let's get rid of that. So it looks like my graphical reading was right, but we don't, usually we can see where it crosses the axis, but if we're unsure, we can always plug in a point. So this is example 1 of using the graph, where we can get y equals negative 3x plus 5 as our equation. Woohoo! So we did that as example 1. So this is method 1, right? When we're given the entire graph and we can visually see it. Now method 2, a little bit different. We aren't given a graph. We don't see anything, but we're given 2 points on that graph. So we can still use the traditional equation for the slope, right? First thing we need to do is find the slope of these 2 points. So remember, we said y2 minus y1, or the change in the height, that up or down, my line, over x2 minus x1, or the run, right? So this is the same as rise over run. And then again, doesn't matter which one we call x1 or x2, as long as we're consistent. So I'm gonna call the first point x1, y1, and I'm gonna call the second point x2 and y2. And now we just plug in, right? So my y2 I labeled as 16, and my y1 I labeled as 8, and my x2 I labeled as 9, and my x1 I labeled as 20. Okay? So let's simplify. 16 minus 8 gives you 8, and 9 minus 20 gives you, yikes, negative 11. What a weird slope. But that's okay. Negative 8 over 11 is our slope. Okay, so we know y equals, y equals, technical difficulties, negative 8 over 11 x plus b. Okay, so now we're in the same situation as before. We need to find b. Okay, so let's plug in a point, right? Same exact thing. I'm going to plug in, let's plug in 9/16. Why not? I don't know. I don't think having a fraction is not as friendly, but that's okay. So I'm going to plug in 9 for my x and 16 for my y, and solve for b. All right, 9 over 1 times 8 over 11. 9 times 8 gives me 72. 72. And 1 times 11 gives us 11 on the bottom. And we're negative, right? So negative 8 times positive 9 gave me that. Okay, equals 16. And don't forget the plus b over here. Okay, now we just have to add that 72 over 11 to the other side, and we'll have our b. Right? Obviously, this isn't going to give us a beautiful number, but let's go through it anyways, because it's good practice to work on finding common denominators and adding fractions, which maybe will lead to my next video. Hint, hint. Let's give us some more space to work here. All right, 72 over 11. Oh boy. And 11 is a prime number, right? So we can't simplify this, unfortunately. Okay, so 16. Let's give it the same denominator, right? Common denominator. So 16 times 11 over 11. And if you need help with common denominators, I will make the next video on that. You are in luck. All right. Now, 11 times 16. I hope you have memorized. Just joking. It's 176. So we have 176 plus 72 over 11. Long story short, we get 248 over 11 equals B. Now, does that simplify? No, it does not. Yeah, unfortunately not the most beautiful number, but that's okay. Doesn't change the process, right? So finally, we are left with y equals and our slope, so negative 8 over 11 that we found before, x plus this lovely fraction of 248 over 11. Sorry that this is a little not beautiful handwriting here. And we're done. So this one only took longer because we had that crazy fraction, but it's really just plugging in the x and plugging in the y to solve for b. So these are the two methods of finding the slopes and equations of a linear function. And I hope this was helpful to clear up the two different ways to do it. And if you have any questions, leave them below. And I'll follow up with a video on adding and subtracting fractions using common denominators. All right, thanks.